Hi, in this video, we're going to be looking at finding the area of regular polygons. Regular polygons are polygons with congruent sides and angles. So I've got one down here, and we're assuming that all of these sides have the same length. If you have a regular polygon, you get this thing called the apothem, apothem. I can't say this word quite right, but the apothem is this line that goes from the center to a side of our shape. So this is our apothem for our shape, apothem. There's also a radius of a polygon. So we know that a radius of a circle goes from the center to anywhere on the edge. The radius of a polygon is a little different. It's going to go from that same center, but instead of going to the middle of one of our sides, it is going to go to a vertex. So this is a radius of a regular polygon. But the apothem makes a right angle with one of the sides. The reason that the apothem is important is we can find the area of a regular polygon by doing 1/2 times the apothem times p. That p is the perimeter of the shape, so perimeter p. So that's if we go all the way around this shape, so perimeter. Basically just add up all the sides. So if we wanted to find the area of a regular decagon whose apothem is 4.36 meters, so that is our A, so we're A, but we get a side length of 12. But 12 is not our perimeter. This is just one side. So we've got to figure out what is the distance all the way around this thing, where each of these sides is 12. So we got 12, 12, 12, 12, 12, 12, 12, 12, 12, 12. So we got 1, 2, 3, 4, 5, 6, 7, 8. Where did I start? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it should be 10 because it's a decagon. So it's got 10 sides on that thing. So our perimeter has got to be 10 for our sides, our number of sides, and then multiply that by our side length, which is 12. So that makes our perimeter equal to 120. So all the way around this thing is 120. If we wanted to find the area of this shape, of this decagon, it will be 1/2 times our apothem. Our apothem is 4.36 times our perimeter that we found. So perimeter is, what was it, 120. All right, well, that's just a matter of plugging all that into our calculator. I can do half of 120 though, that's 60 times the 4.36. So I'm going to type that in my calculator here. And we get 261.6 meters squared. So without all the explanation, that actually goes much faster in actual practice. If we've got a pentagon, our apothem is right here in the middle. It's making a right angle with our side. And then our sides are each 35.3. So 35.3, 35.3, 35.3, 35.3, and 35.3. So our area has got to be 1/2 times our apothem. Apothem, I keep saying it wrong. 24.3. And then the perimeter of our shape. Which is all those 35.3s multiplied together. So I got 1, 2, 3, 4, 5 of them. You could add them all up, a bunch of 35.3s, or we can just do 5 times 35.3. That is a bit of a mess. So I'm just going to type all that in my calculator. So when I type that in, I get 2,144.475 centimeters squared. And that's it. Now, this last thing is kind of just reminding us a little bit about what's going on with regular polygons. So, in a regular hexagon, we got to determine the measure of the numbered angles. We want to label the apothem as A and side as S. So, I'm going to do that quick because that's what we were just talking about. The apothem is this side right here that is perpendicular to one of our sides, S right here. So this is our S, it is one of our sides, and our apothem goes from the center and is perpendicular to one of the sides. So if we want to find the measure of the numbered angles inside of a hexagon, we need to remember our formula for the internal angles in a polygon. That is our n minus 2 times 180. So this has 1, 2, 3, 4, 5, 6 sides. So I got to do 6 minus 2 times 180, which is 4 times 180, which is 720. So this is our total angles. If that's our total angles, then each one of these angles has got to be the same. So then each one of these angles has got to be evenly divided. So a single angle, since this one is regular, means that all angles are congruent. We want to take 720 and we're going to divide that by 6 to figure out what just one of these angles is going to be. So that's 120 degrees. So this angle right here is 120 degrees. Now, if this thing is cutting our hexagon in half, then it must cut that 120 in half as well. So if this is 120 and this angle 1 is half of that, the measure of angle 1 has got to equal 120 divided by 2. So the measure of angle 1 is 60. By that same logic, we can also find the measure of angle 3, because that one is also a 120 that got cut in half. So that's also got to be 60. Now, if I blow up what's going on in here, I've got a right triangle over here where I've got my apothem. I've got this angle 2 that I'm hunting. I know this has got to be 90 degrees and this has got to be 60, just like 1 and 3 are. So I could find angle 2 by knowing there's 180 degrees inside of a triangle. So that's the measure of angle 2 plus 60 plus 90. If I subtract that 60 and 90 from both sides, we get 30 equals the measure of angle 2. There we go. We found all of our sides and all of our angles. That's it for our video on regular polygons. Just keep in mind that apothem goes from the center and then is perpendicular to one of our sides. Don't let them throw you off if they give you just a single side. You've got to multiply that by the number of sides so you can find that p. P is the distance all the way around the polynomial. Thanks for watching. Bye-bye.